Welcome to MyProjectBazaar. Title: New Space Vector Modulation Scheme for Multilevel Inverter which directly vector quantize the reference space vector. Modify title: Space Vector which directly vector quantize reference pulse width modulation. Modify abstract: a new space vector based sigma delta modulation scheme for any general n level voltage source is proposed in this paper. Directly quantize the reference space vector. The proposed scheme use sigma delta modulation is quantize implement proposed space quantizer. A new scheme is proposed directly quantizing the space vector in two level of vector space. And the multi-level inverter vector space is proposed. The quantizer is a defined parallelogram with the inverter switching and then vector its vectors. These properties of integers and switching vectors 60 coordinate instantaneous of voltage space vector. So the proposed scheme is implement for 5 level inverters realized open and winding induction motor. Objective: the proposed scheme is implement for 5 level inverter is fed open in winding induction motor and result have been presented. The performance of proposed scheme compared with the performance of pulse width modulation scheme different speed range. Motivation: the difference between the pole voltage of 3 level inverter A and B is the effective pole voltage. It's a 5 level inverter realized with open end winding induction motor. Existing system: the recent decades of development multi-level inverter has to be led introduction of the new simpler flexible modulation scheme. The modulation and control strategy in multi-level inverter can be broadly classified into the voltage level. It's based on algorithm space vector based algorithm. Space vector scheme have wider linear modulation range, has lower passband harmonics and convenient digital implementation. Disadvantage: low quality, not efficient and not reliable. Proposed system: the proposed is the principle of the vector quantization used to implement the quantize of sigma delta modulator. Non-overlapping of each code is a vector centralized a particular region. So the random vector particular region is a rounded single code vector. This integrated error space is proposed sigma delta modulator in random nature. It's a mapped of the multi-level inverter voltage vector space. Proposed system advantage: it reduce total cost, reduce power loss and reduce installation area. Flow diagram: 3 level inverter design, 3 phase difference input, delta sigma modulation, space vector quantizer, pulse width modulator SVM and analyzing waveform switching and output. System architecture: so 3 level inverter, 3 phase difference input, sigma delta modulation and space vector SVPWM and then space vector quantizer, switching state, waveform analysis, output. So we have used 3 level inverter design for the scheme of space level in multi-level of source inverter. 60-degree coordinate utilize this instantaneous of reference space vector. So it's a 5 level inverter realize open end winding induction motor. 3 phase different, it will be on AC alternating current waveform. Is the alternating current waveform is the multiple class of D amplifier threshold switching input. So SVBWM pulse generator, it's analyzed waveform of switching states. It compare the respect of carrier frequency and suppress the effect of sampling frequency. And delta sigma modulation is the sampling rate of Nyquist reference input signal, adjustable speed and DC link inverter resonant back to the 0. So This is the use case, class diagram, sequence, here models and model description same. It will be separately get the output. This is the new space vector modulation 5-level inverter of open-end winding induction motor of circuit diagram. So the first you can design 3-level inverter A and 3-level inverter B. 3-level inverter A you can use IGBT diode. 3-level inverter B also you can use IGBT diode. Why we are using IGBT diode means it will be on high quality and accuracy output you can got it. So first how many outputs you can provide. So the IGBT diode we have provided the switches S1, S2, S3, S4, S5, S6. Upper side you can use 6 kind of switch, lower side 6. So both 12 switches you can get 3 output VA, VB, VC voltage inputs. So same right side also the 3-level inverter B, 3 kind of output you can provide. You can get the C1, C2, C3. So you can get this kind of A1, B1, C1, A2, B2, C2, A3, B3, C3, A4, B4, C4. So 4 of the output you can get commonly connect to the motor, open end winding induction motor. So the winding induction motor you can use for induction motor. You can how to design means, so open end and induction motor you can apply for straightly, otherwise you can connect the inductor and resistor also. So you can provide the power supply 200 voltage for DC voltage source. You can get the capacitor 50-50 for separately for the whole circuit. The circuit it will be take the first 3 kind of output VA, VB, VC. After you can got the output of switches. So simultaneously switches after current and voltage measurement you can use. So 3 kind of space vector output you can got it. So this is the output.